Hi, this tutorial is going to be about how to use Autocad to 3D model a basic toilet using some really basic Autocad 3D commands. Yes, of course, you can download a 3D block from any plumbing fixture manufacturer, but if that's what you want to do, then this tutorial is not for you. Before we start modeling, there's one thing that we need to kind of understand, and that's basically what a topographic survey is in contours and how those topo lines represent a 3D object. So I'm going to talk about that really quickly just so we have an understanding, because that's the concept we're going to use to do the modeling. If we take a look at this image here, we have a three-dimensional mountain, right? And basically what we do is, there a better image here? Three-dimensional mountain here. And basically what a topographic survey is basically taking that mountain, slicing that mountain horizontally at various vertical increments. So in this diagram, it's showing that these two mountains, we're cutting it every 10 feet. 10 feet, we cut the mountain. 10 feet, we cut the mountain. Each time we cut it, it's going to follow the contour of that mountain at that specific elevation. All right, so if you walked along this line, any one of these lines, you would always be at elevation 20, and you would follow the mountain in and out, following along elevation 20, right? If we did that and we mapped out those lines, and then we flattened those lines so that they were all on the same plane, we would get something that looks like this, which is a contour map. And this is a 2D representation of a three-dimensional figure. Okay, and this is when you guys take site planning or surveying, this is exactly what you're doing. You'll walk up, a mountainside or something, a hillside, you'll take your transit, you'll measure the elevations of those specific spots, and you'll just move along the mountain until you mapped out all those contours, and you'll translate that into a two-dimensional drawing, because we need some way of representing vertical heights in 2 dimensions, right? If we're going hiking, we need to know if we're walking up a mountain or walking down a valley. And you could tell that by looking at these contours, right? So if this line is 30, right, which is represented here, and I move down to the next line, which is 20, I know in this direction I'm walking downhill. And sure enough, if I look at the three-dimensional model, I'm walking downhill. Vice versa, if I'm walking up, I see these numbers are going up. Same thing here. So that's what a contour map is. And what we're going to do is take that. We're going to take a bunch of lines. I'm going to take a polyline. I'm just going to draw a polyline. Just draw something, right? They could be a contour of a mountain, right? That's a contour of a mountain. And inside of that, I'm going to draw another series of polylines. That represents another set of contours at a different elevation. Right now, it's all flat. Right now, it's all flat. It's all on the same XY plane, right? They're all coplanar. But I'm going to continue to draw a little bit more just to give a little bit more of a surface here. Draw another one. And then another one. The more you draw, the smoother this will be. So I just got to close this. Okay. So right now I have all of these on the same plane. All right. But what I'm going to do is I'm going to actually move them vertically up in the air. So in space, actually going to occupy the third dimension, the Z. All right. And to do that, I'm just going to select, I'm going to leave this one at the bottom. I'm going to select all of these, and I get my little UCS right here. I'm going to hover over the blue and move it vertically. I don't know what makes sense. 20 feet. Let's see what that looks like. Here we go. Another 50 feet. Okay. All right. Now, if you look at these lines, they're not all on the same plane, right? They're all at different elevations, 50-foot increments. So Loft command basically is a command that will basically connect these contours together to create that surface. So if I go to extrude and hit Loft, I'm going to pick this first one at the bottom as my first line. Then I will click the next one. And as I click them, it's going to generate a surface between those two P lines. And then if I pick a third one, it will make that one. And then if I pick the third one here, it will do that. Now these P lines are, really jagged looking. So that's why this shape looks as weird as it does. But you'll get the point. So I'll do that again. Right. So generate the surface across those polylines by using the contours of what that shape was, and it's just completely random, right? You could do this with anything. You could do this with circles. Right, so if I move these shapes vertically, right, so I have these circle shapes. If I do Loft and I pick these shapes, it will create a shape with that. Right, so it's only just by drawing a few circles and I could get a fairly complicated shape. Yes, I could also draw this as a profile and revolve it around, but some things you can't do that. This happens to be a circle, right? But you can do that. Right, so
using that idea of contours, we're going to use that idea to construct this model, and we're going to draw basically the contours of this object at various elevations, and we'll move them into place, and we'll use the Loft command to create that surface. So what you're going to be seeing is me just drawing those contours or profiles of this model, and I'll be moving them into place. So here what you see is those other P lines that I drew, and I moved them over to the location of where ultimately the model will be. And what I'm doing now is, again, I'm moving the contours of the profiles vertically into its position. And some of the profiles are actually the same profiles, right? If the part that I'm drawing is basically an extrusion, and if I'm cutting it a couple of times and it's really the same profile, I could just copy them twice or three times, so that I have an area where that extrusion will match those profiles, right? So as I do that, I'm also panning and orbiting around the model to see if the profile is really looking like what it's supposed to. And as I need to make edits to it, I'll continue to edit those contours of those profiles, right? So here I offset one of the profiles just inside about 1/2 inch or so, because I wanted the pedestal of the bowl to basically taper as it moves up. So as I do that, I offset inside, and then I lift it up into its position. So I'm doing that several times to generate that contour, right? So now you can see the shape starting to come together, but again, these are just the contours right now. There's no surface, it's just a contour. And as I finish that, you'll and I start using the lofting command, you'll see that surface start to develop. All right, now I'm editing the polyline or the contour or the profile, whatever you want to, however you want to describe it. The top contour, right? The top profile of where the basic seat is, because that portion of the bowl does extend underneath the tank. So I had to edit that polyline to extend underneath the tank. So what I did was I drew the rest of it, the portion of the P line that didn't exist, that extends underneath the tank, and I joined it together with the original P line, and then I copied that down, because if you look at the edge of the bowl or the seat area, it does extend down vertically, sort of as like a lip or an overhang around that perimeter. So I took that profile and lowered it, copied it down about 1 inch or so, 1.5 inches, because then again, once I make that profile and you make that surface, it'll create a sort of lipped surface there. And here I'm just rounding some of the edges that I had for the lower portion of the bowl, just again to make sure that I have rounded corners and edges, because again, the more detailed, the more realistic I make it, the better it's going to look, right? So if it had sharp 90-degree corners, that's not as realistic. But if I can start to smoothen it out so that it does look like how a surface of the tank would be, it'll make the model look that much better. Even if it's not 100% accurate, at least those little subtle details will definitely make the model look a lot better. So here I'm, again, modifying those P lines to have smooth edges. Some of this, again, as I model it, some of these things come to mind that, as I model it, okay, it's sharp corners, maybe I should round it. Like, it's not something that's, that's thought through 100% from the time that I start modeling it. As you do it, some of these things kind of come to mind, and the more you do it, the more you'll be able to see it. And so I'm taking that profile, and again, from the top down this time, I'm offsetting it and dropping it down, right? When I started the beginning portion of this, I was starting with the lower profiles and extruding it up or moving it up. Now I'm kind of working my way down so that I can get that lower portion of the bowl to look like what it needs to look like, right? Because it oftentimes it's a bowl shape, right? It's rounded, so I want to make sure that curve, comes down and then meets where I developed the lower portion of it. So again, I'm lowering it down, I'm offsetting it so that I can see that I'm getting a curve. And if I'm happy with the curve, then I'll leave it alone. If I'm not, I can always erase the contour and start modifying it. And what you'll see is, this is sloping, and it's kind of sloping at a straight line, right? But the bowl is more rounded. So one of the things I'm going to be doing here is, again, I'll be shifting some of the profiles up. I'll be offsetting them inside a little bit just to get a more rounded shape as opposed to just like a straight line sloping shape. So again, at this point it's easy to do. They're just polylines, and I could very easily manipulate them without too much effort. But you do have to kind of look at it and kind of get a sense of what it's going to look like. It's probably taken maybe 15 minutes at this point to do this. But again, the more you do it, the better you'll get. The quicker you'll be able to visualize this and be able to kind of pull apart all the objects, right? So right now, all the commands I've been using so far are everything that we've talked about. I'm using P lines, right? I'm using my move command, whether it's a 3D move command or just a regular move command, and moving polylines either to the left or right, or moving them in the Z axis, right? That's all I'm doing at this point. It's really only going to be a handful of commands to be able to model this, and it's going to look a lot more complicated than it actually is. So now I have the majority of the profiles drawn for the lower portion, and I'm just making sure, before I go over to the next step, I'm just, orbiting around the model just to make sure that it basically looks like what it's supposed to look like from a profile standpoint. But again, this is just it's a wire frame at this point, but I'm having to kind of visualize what the surface might look. And the more profiles I put here, one, the more accurate the model will be, but two, it'll allow me to visualize it much easier, right? The more lines that I have on it that define the surfaces, even though it's a wireframe, it'll allow me to see that surface a lot better, right? So similarly, if you were looking at a contour map of a mountain, the more contours you have, the closer the increments of those contour maps are, the easier it is for you to visualize. If you only had the mountain's 1,000 feet and you only have one contour at 0, one contour at 500, one contour at 1,000, it's hard to see the detail of the mountain and the slope. But if there's a contour every foot, it'll start to develop that surface area. So here, because I'm satisfied with the sort of overall outside shape of it, I'm taking that inside line, that inside poly line that defines the opening of the bowl, and then again I'm doing the same thing that I did before. I'm offsetting it inside, half an inch or so, and then I'm bringing it down vertically on the x-axis, and doing that to basically define the shape of the interior of the bowl, right? The bowl is not solid, the bowl is actually hollowed out. So again, I could do the same thing, create those contours and again bring them down into the bowl, and I'll be able to use those later to develop that surface, right? And here I drew the polyline that defines the tank, right? So I'm rounding the edges. I bring in the edges slightly so they're slightly angled just to give it a little bit of a visual interest, right? Again, depending on the design of the bowl, it might be different. It could be a more rounded tank. It could be a rectangular tank, right? This is just, I just pulled in the edges just to give it a little bit more of a difference, visual interest. And again, same idea, because it's mostly rectangular. I have one profile at the bottom for the tank, and I copied it up vertically, about 12 inches to define the top of the tank. And then I offset it outwards, and then took that P line and copied it up, which is basically the cover of the tank, right? And if you look at the cover of the tank, depending on the style of the design, the tank cover, the lid, oftentimes is a little bit wider than the actual tank itself, right? So that's why I offsetted it outside. So here I'm just making a copy of it because, and I'm copying the polylines only because just in case, you never know, something might happen. I make a copy of it in case, something happens and I can't go back, or I want to go back, I can always go back to the copy, right? So that's always a good idea to make sure that you don't want to waste the last half hour of work because of something that you just can't undo, right? And it happens. So here I'm just looking at these polylines, and I'm tweaking them a little bit. I'm starting to loft it, right? The command is loft. It's under the extrude button, and I'm starting to loft these polylines to create that surface, right? And so I'm just tweaking them. I'm taking the first two and then the third one, and as I start to pick all the other subsequent vertical profiles, you can see very easily and quickly that it's generating the profile or the surface of this object, right? I have some objects floating around in the background. That's why it kind of screen turns green, because I'm actually looking through an object. So as I start picking some of these objects, I'm realizing that I'm actually picking the profiles that define the inside of the bowl, right? And obviously that's not correct. I can't generate the surface on the outside directly to the inside of the bowl, and it's actually creating a situation where it's not creating any more surfaces, right? So I'm just going back in and editing some of these profiles, because some of the profiles that were defining the inside of the bowl were actually overlapping or actually wider than the surfaces that define the outside of the bowl. So in theory, it's sort of, the void of the bowl, if you will, the void of the bowl is actually penetrating the skin of the bowl. So I have to actually edit those interior profiles to make sure that they actually stay within the surface, right? So here I am again extruding some of these profiles, and I'm getting up to the top of the bowl, and I have to make sure, again, zooming in, orbiting around, making sure that I'm actually picking the correct profiles, because there's a lot of lines here, but you can see the surfaces are starting to develop, and it's starting to look like something, right? So again, it might take a couple of times, but as you start to loft it, you'll be able to see the shape come together. If you're picking the wrong line, you'll be able to see it very quickly, and you can tell, once I have these profiles, it's very quick. The lofting part is actually, less than a minute. As if all my profiles are drawn correctly, just pick loft and pick all the polylines, and that's it. It's as simple as that. The hardest part is really generating these profiles. So I did the outside, and it seemed to look okay. Now I'm tweaking the inside, right? I just, I didn't complete the outside because, with all of those surfaces, it got a little bit too difficult to see what was happening inside the hollow of the bowl. So I just didn't, complete that task, because I know it was working. So now I want to focus on the inside of the bowl. And here I'm just tweaking those polylines because again, those polylines were kind of extending outside the surface area. So I'm just pulling them back. I'm shrinking the profiles a little bit just so that that hollow of the bowl I'll be able to carve out of the mass of the entire toilet. So I'm just tweaking these as I go, and again trying to visualize where these profiles should be. And again, it's not an exact science. This is somewhat just really visually as if it looks correct. But again, as long as I have the proportions of it and I'm basing this on an actual drawing, then I have a pretty good shot at making this this model fairly accurate. Now, again, if I was modeling this in terms of, using it for a manufacturing process or 3D printing it or sending it to, a CNC machine, obviously I would spend a lot more time to try to get this model accurate. But for our purposes, or just the sake of just modeling something for the purposes of putting it into a building model or space model or something to just, make a rendering, right? This is, more than accurate for our needs. No one's gonna really measure, the actual dimensions of a toilet bowl if you're talking about a rendering. But, with that said, it still needs to be proportional, right? So if it's just out of, scale, if it's way too big, if the seat height is way too tall or way too low, those things are going to be very obvious. But if those, main general dimensions are proportional and scaled appropriately, it will look fine. It might not look like the exact toilet bowl that you've selected, but again, for all intents and purposes, it's good enough for this purpose. Obviously, again, if it were, you have to build things, draw things, and model things, based on its purpose, right? For our purpose, it's perfectly fine. For manufacturing purposes, no, this is not okay. But even if we were using it for manufacturing purposes, the process and the procedures would basically be the same thing, right? It's just that the level of accuracy would be a little bit different. So again, I tweaked those polylines for the interior of the bowl. I re-lofted the exterior to, again, get a sense of everything, making sure everything is proportional, making sure everything does look like basically what it should look like. And I'm just, orbiting around. I'm taking my time to make sure that these lines look like what they need to look like. So sometimes I'll change the visual style view of it just so I could see some of these lines a little bit clearer so that I can select them a little bit easier, right? So again, spending the time to tweak this to make sure that, it will look, as correct as possible. And again, like I'm offsetting those lines inside a little bit because it's a little bit too wide, right? It's extending past. So some of these lines you could see that they're actually rendering as white, like right in that area, versus the gray outline. So that tells me that those lines are actually penetrating outside the shell of this. So again, I offset it inside and I delete the other ones to make sure that, again, those lines fall inside the tank. And there you go. They're inside the tank now. And again, spending the time to look and navigate around. And at this point, maybe it's 20 minutes, 25 minutes of actual modeling this. And that is the surface, or those are the polylines or contours that define the inside of the tank, which is actually, a void, right? So again, I could pull that out a foot, 2 feet out from the original model, right? Again, using a specific dimension. That way, when I'm done with it, I can move it back, right? Very easily and very accurately. So here I am modeling or lofting out the profiles of the interior of the bowl. Actually, this is the negative space, right? This is the hollow of the bowl. So I will move that hollow, that solid that represents the hollow part of the bowl, into that model that defines the bowl itself, because that is modeled as a solid, right? And I'll use my solid subtraction tool and be able to subtract that from the model of the tank. And right there is basically what happened right there. In the blink of an eye, the solid subtraction tool allowed me to subtract out that void, right? What I probably should have done is probably made a copy of those profiles for the tank. But again, I forgot, and at this point, it looks fine and it's probably good. But if I wanted to, let's say, use those profiles again to build a different tank that's very similar to that, I would have to basically redraw those. So I probably should have copied those out so that I would have a copy of it to save myself some time. And the tank, again, is very easily, I used the loft command and I lofted the tank shape. I could have extruded it as well. I also extruded the tank cover. And what I did with the tank cover is I actually applied the smoothing tool onto that just to give it a more rounded shape. And that's essentially the tank, right? That's the tank and the actual toilet, right? And so from here on in, what I'm going to do is I'm going to add some more details to it, right? I'm actually going to model the toilet seat cover. I'm also going to model in the flush lever as well. But again, all those little things are going to add a little bit of detail to it to make the model look that much better. And so here what I'm doing is I'm drawing a polyline that's going to define the shape, or at least the path of the trap, right? So every toilet has a trap, and a lot of toilets, it is actually exposed on the outside. You can see the shape of it. So here I'm just roughing out the shape of that trap, seeing if it's proportionately okay with that tank. And I'm just drawing it with a bunch of P-lines, and then I take the P-line and create a spline with it, or a curve, right? Because the trap is not made out of segmented pieces. It is a smooth curve, although if it wasn't smooth, then obviously things will get trapped in there, right? So that's the profile of what that is. Then what I'm going to do is draw a circle that's going to define the shape of that, which is basically a circle, right? And I'll draw that circle at the end of that polyline, and then I'll use my extrude command and extrude that circle along that path. So instead of extruding in a vertical line, I will extrude along a path. So here, in order for me to draw a circle that's basically perpendicular to that curve, I need to rotate my UCS, right? So that the Z-axis is pointing in that direction, not vertically anymore, but sort of left and right if you're looking at this view. So that's simple enough by clicking on the actual UCS and just grabbing the grips and rotating it so that I can draw a circle in that plane, right? Right at the end of that curve that defines that trap. And so once I draw that circle, I could take my extrude command, select the circle, and then type P for path, and I'll be able to extrude that circle along that path. And that's basically the trap, right? In this case, it doesn't matter that the trap is actually hollow or not, because I'm just looking for the surface area on the outside to be exposed on the toilet, right? So once I have that shape, I can move it in place by taking the center of the circle, placing it at the center of the toilet, and then moving the bottom of that up to where the base of the toilet is, where basically it would meet the floor, right? And obviously it doesn't stick out like that. It's more embedded in the actual toilet itself. So again, accuracy is not so important here, as long as scale wise and three-dimensionally it looks accurate, because no one's really going to measure this, but you can tell whether or not it's accurately drawn or not. So I just positioned that in its place, and here I'm rendering this in a realistic sort of visual style, and you could see where that trap is and how it intersects with the tank. If I wanted to refine this a little bit more, I might trim, make that lower portion of that tank a little bit maybe narrower, so that some of the trap is a little bit more exposed. But I'm quite happy with this, and it looks like what it's supposed to look like, right? It might not be 100%, but it looks like what it needs to look like. So here I'm just taking the polylines again and using those polylines to create the seat now. So again, I'm moving it up to 14 inches to basically the height of the toilet, and I'm taking that profile, and I'll be able to offset that inboard to basically create the seat, and then I'll cut out the opening in the center, so it will look like a seat as opposed to a solid plate. But for the cover itself, I'll be able to use that profile, that profile there, and be able to again extrude that to create the actual seat cover, right? So these are my P lines for the seat and the seat cover, and I'll take those P lines and extrude that up to create the seat. And once I select both those polylines, it'll generate the outside solid and an inside solid, and I'll subtract the inside solid from the outside solid, right? And that's basically the solid of my seat. And again, adding the smooth command to that seat portion, it creates those rounded edges to make sure that it's a smooth curved seat. And for the tank, for the cover itself, the same thing. I extruded that an inch or so, applied a smooth on top of it, and it created this smooth seat for my toilet. And once I move that in place, it completes that part of it, right? So here I'm just building the flushing mechanism, the handle that's on the outside of the tank, and it's basically just a circle. Again, just looking at the shape and just breaking it down to its basic shape. It's basically a circle with a rectangle that's extruded for the lever. And again, I could spend a little bit more time on this and make it, a little bit smoother. But for the scale that I'm for this model, it's going to be more than enough for what I need to do. So again, I'm just, again, putting the UCS along the plane that I want to draw my shapes will allow me to draw directly on a different plane other than the normal XY plane, right? The world coordinate system. This becomes a user coordinate system because it's user based, and I'm moving it to a specific location for when I want to draw. So again, I'm just drawing, a rectangle that's going to represent the profile of that lever, and I'll just extrude it. And so now this is the flush lever that will be on the outside of the tank. So again, not going crazy in terms of the detail. It's basically a circle with a box, right? And again, for the purposes of what this is going to be for, this is completely adequate. I could spend the time and kind of round the edges and taper them. But again, for this purposes, it's perfectly fine. And again, I'm just moving it in its place, and because I know exactly the position of this model relative to where I drew all my contours, I could just move them to specific dimensions, and it'll place it where I need it to. And that's basically modeling a toilet. Again, the hardest part is really coming up with those profiles. That's going to take the longest time. The rest of it is fairly quick, and you see, I modeled a different style of toilet as well, but using the same ideas and concepts here. Basically a handful of commands: lofting, polyline, moving, understanding your UCS so that it makes things a little bit easier to draw things on specific surfaces. And if you can model this, you could basically model just about anything else that we'll encounter.